Hello Matrix, my name is Olwetu Getse and I'm a project manager with the South African Institute of Chartered Accountants. Normally at this time of year, we'd be seeing you at your schools or you'd be with us at one of our Tutuga development camps. But because of the situation, we aren't able to do that currently. If you're feeling a bit frustrated and annoyed, we completely understand because we're feeling the exact same way. And we understand how tough it must be without having the extra support to help you through. And whilst we can't be with you in person, we're trying our best to be with you in the only way we can right now, and that's digitally. To help you with your matric revision, the team and I have reached out to some of our favorite educators to create a series of videos in the most common problematic topics that matrics struggle with. We hope that these videos are able to assist you and help you feel less alone during this time. All the best for your matric exams and good luck matric class of 2021.
Okay, as indicated in the previous video, this lesson is exclusively for SAICA, which is the South African Institute of Chartered Accountants. Okay, the topic on hand is Euclidean Geometry at grade 11 level. We're looking at a few theorems and examples thereof. Okay, the textbook that is in use is The Clever, Keeping Maths Simple. We're on page 277. This is example 1. So the question says, given AB is a chord of the circle center O. Okay. D is the midpoint of AB. As indicated there, it's the midpoint, so those lengths are equal. Then we are told that AO and OD are joined. AO is equal to 10 centimeters, AB is equal to 16. So that is your 16 centimeters there. The question says calculate the length of OD, which is this length here. Okay, so working with lengths, what should come to mind is the Pythagorean Theorem. The Pythagorean Theorem was introduced to you for the first time in grade 8. Okay, so the Theorem of Pythagoras says that in any right-angled triangle, the hypotenuse squared is equal to the sum of the other two sides squared. Okay, so at this point, we know that we need a right angle triangle, which in this case we don't have. I have to actually highlight to you the theorem that is going to be used. This is on page 312. Basically, if we have a right angle triangle, then we can conclude that those lengths are equal. And the theorem that is used there is perpendicular from center to chord bisects the chord. Theorem 1b says that if these lengths are equal, if a line drawn from the center bisecting the chord, which means to say cut the chord in half, then that angle will be 90 degrees, or this length will be perpendicular to the chord. Okay, so as you can see, these lengths are equal. So AD is equal to DB. So we can conclude that the angle D1 is 90. Which then in turn I can use the Theorem of Pythagoras. Remember, in geometry, every statement needs a reason. As long as it's not on the diagram, it needs to be stated. Okay? With a reason, of course. So as we said, we're going to first indicate that D1 is equal to 90 degrees. So angle D1 is equal to 90 degrees. And the reason there is bisector from center. The whole theorem says that a line drawn from center bisecting the chord will be perpendicular perpendicular to the chord. But by saying bisector from center, you'll get the full mark for your reason there. So with that, I'll add now 90 degrees to the diagram. Okay. So as you can see, AD, we need the length of AD. We know that AB is 16. We can't just go and say, okay, that is 8. We have to give a reason why. Again, if it's not represented on the diagram, we must state it. Okay, so AD, the length of AD is equal to 8 centimeters. Why is that equal to 8 centimeters? Because it's given that AD is equal to DB. That was given to us. Okay, so there we got 8. Now we can apply the theorem of Pythagoras, which says the hypotenuse squared, so I go 10 squared, is equal to the sum of the other two sides squared. So it's going to be 8 squared plus OD squared. And your reason here is Pythagoras with angle D1 equals 90 degrees. Okay? You can leave the Pythagorean part out. But if you're going to leave the angle that is 90 degrees out, you're going to lose the mark. Okay, so very importantly here, if you're stating the theorem of Pythagoras, you must say which angle is your 90 degree angle there. Okay, so as we said, D1 is 90 degrees. So that is basically going to be 100 minus 8 squared is 64. Is equal to OD squared. 100 minus 64 is 36. The square root thereof is going to be 6. Therefore, OD is equal to 6 centimeters. Okay. Okay, in example 2 on page 277, we are given that PQ is a chord of circle center O. The radius OS, there's an S there, OS is perpendicular to PQ. So if OS is perpendicular to PQ, we know that that angle is going to be 90 degrees. Okay, as indicated in the diagram as well. Then if R2 is 90 or R1 is 90, we know that PR is equal to RQ. Why? Because it's perpendicular from center to chord, bisects the chord. Okay. Then we are told, and cuts QP at R. We are told that the radius OQ is 25. So if that is 25, then OS is also 25. Why? Because both is your radius. From center to circumference is your radius. Then we are told that PQ is 48 units, not centimeters, units. Calculate the length of SR. So now there's no way of calculating SR without first calculating OR, because Pythagoras can be applied there, and then subtracting 25 from subtracting OR's length from 25. Okay, as we know that is also your radius. Okay. So firstly, to apply Pythagoras, I need to know this length here. Okay. What's that length here? We know it's going to be half of 48. So we say QR is equal to 48 divided by 2. Okay, which is 24 units. So there goes 24. All right. So with that, I can now calculate the length of OR by using Pythagoras, the Pythagorean theorem. So we set that up. We set the hypotenuse squared, which is 25 squared, equals OR squared plus 24 squared. And your reason there is your Pythagoras with angle R2 equals 90 degrees. Again, it's very important to state the 90 degree angle in the triangle that you're using. So 25 squared is 625 minus 24 squared, which is 576. I think we'll just get the calculator quickly. 576 was correct. Equals OR squared. So 625 minus 576 is going to be 49. So OR squared is equal to 49. And the square root thereof is going to be 7. Now remember, at this point, normally when we introduce the square root is going to be plus and minus. But since we're busy with length here, and length is of course never negative, so therefore I'm going with the positive part only. Okay, so that is going to be 7 units. Alright, so we can put in 7 there. But remember, what was the question? The question was for RS, to calculate RS, which is this length. But remember that OS is also a radius, and that is going to be 25 here. Okay, so to get RS is simply going to be, so it's going to be RS is simply going to be 25 minus 7, which is simply 18 units. And what's the reason there? As you can see, that OS was not given 25 on the diagram. So whatever is not on the diagram, we have to state it. So the reason here is simply going to be radius. Okay. We can say that RS is your radius there. Alright. Okay, so this is a question that learners normally have a problem with when it comes to the exercises. Number 4 is also an issue, but the only thing that the learner has a problem in number 4 is that they must be reminded to divide 2k squared minus 2 by 2, which gives you k squared minus 1 for pm. Okay, but this one here, it normally comes back every time. The learner just doesn't understand how this x gets involved in the diagram. Okay, so I'll try and explain this out today. It says calculate, given circle, center D, DE is perpendicular to FG. So if this is perpendicular, we know that that length is equal to that length. Why? Because perpendicular from center to chord bisects the chord. Cutting FG at M. Then we are told that FG, which is this length here, is going to be 24 units. So in other words, that's going to be 12 and 12. Then we are told that EM is 8 units and MD is X units. The question says calculate radius FD. Okay, so in other words, they're looking for this length here. Okay, we can just draw that in. That's what we're looking for. Now remember that this is your radius, FD is your radius, as well as ED is your radius. So in other words, FD is equal to x plus 8. Why is that equal to x plus 8? Because it's equal to ED, which is also your radius. Alright, does that make sense? And remember that ED is the same as FD, which is the same as DG. Okay, if I needed to draw a line there, it would also be the same. Okay, so if that is x and that is 8, the combination of that length is going to be, or that length ED is going to be x plus 8. This is FD, which is also now x plus 8, as they've indicated there, because of the fact that it's a radius. Remember, whatever is not on the diagram, you must state it. Okay? Then, if that is 24, then FM has to be 12. 12 units. Why does this have to be 12 units? Because we are given that it's perpendicular. So perpendicular from center to chord, bisects the chord. Okay. So at this point, so that's going to be 12 there. So now we can apply by the theorem of Pythagoras now in this triangle. Okay. The question says to calculate FD. So in other words, once we solve for x, we can add 8 to x to get the length of FD. Okay. So the theorem of Pythagoras is going to be x plus 8 squared equals x squared plus 12 squared. The reason here is Pythagoras with angle M1 equals 90 degrees. Okay, the angle M1 is equal to 90 degrees. Okay, so now it's just a matter of solving for x here. So it becomes simply x squared plus x times 2 times 8 is going to be 16x plus 64 equals x squared plus 144. Now it becomes an equation that needs to be solved. Of course, that cancels. If I say x squared minus x cubed would cancel. So 16x is equal to 144 minus 64 should be 80. Let me just say 144 minus 64. It's 80, yes. So I divide by 16 gives you an answer of 5 units. So x is basically 5 units. But I haven't answered the question. The question was for FD. So therefore, FD is simply 5 plus 8, which is equal to 13 units. Okay, already we have said that it's x plus 8 because of radii. So if I hadn't said it here, I would have said here radii at this point. Okay, at this point. With that said, I just realized that I forgot to write something in here. We said that, remember, every statement must have a reason. Okay, that was QR was 24. Why is that 24? Because perpendicular from center to chord bisects the chord. Okay, sorry about that. Okay, so now we're looking at Theorem 2. Theorem 2 says the angle that an arc of a circle, which is this here, the arc of a circle, subtends at the center, which gives off at the center of the circle, is twice the angle subtended at the point on the circle's circumference, which is that there. So this angle here is twice as big as that angle there. Okay, as you can see here, if that is the case, then this would be 2x and x there. So if this is 50, then that would be 25. If this is 25, then that's going to be half of that, which is 12.5. If that is 50, then that is 100. Okay, why? Because the angle at center is twice the angle at circumference. Okay. Okay, so at this point I think it will be a bit unfair just to go straight into the example, because the example is a bit complex if this is the first time you're looking at this theorem. So I'm just going to go look at exercise 12.2. I'm going to look at a few examples, just explaining, not writing anything down. It's basically always the center of the circle in each of the diagrams. The question says, determine the value of the variable in each case. So as you can see here, A is at the center. So the angle at the center is normally the bigger angle. Okay, so A is equal to double 32y. Angle at center is twice angle at circumference. So A is equal to 64. Looking at B, angle at center, again this arc here is subtending that angle at the center. The same arc is subtending the angle at circumference. So if this is 64, then B will be half of 64. Okay, so 64 divided by 2 is going to be 32 degrees. So B would be 32 degrees. If you're looking at C, again angle at center is twice the angle at circumference. Okay, as you can see, let me just show you that angle at center, this arc here is subtending that angle at center, same arc, subtending angle at circumference. So that C angle is half of 110, which is 55 degrees. Okay, for D, again angle at center is twice angle at circumference. So D is going to be also 55 degrees. Okay, looking at E, E would simply be double this angle here. So again, angle at center is twice angle at circumference. So E would be 200 degrees there. Okay, this being the last one I'm looking at. So if, as you can see here, this arc here, this is called the major arc, is subtending the angle at center, which is F. Okay, the same arc is subtending the angle circumference, which is this angle here, which is 120 degrees. Can you see there? So F is going to be double 120, which is 240 degrees. So that's F is 240. To get G is a revolution, angles around a point. Okay, so G is equal to 360, because angles around the point adds up to 360. 360 minus 240, which gives you an answer of 120 degrees. So G is 120, and then again, angle at center is twice angle at circumference. 120 divided by 2 will give you 60 degrees there. All right. So now we're looking at the Theorem 2, this example 1, on page 282. All right. The question says, circle center O with point A, B, and C on the circumference of the circle. Angle A is 43 degrees. Calculate the size of O1. So the first question is to calculate the size of O1, which is this angle here. Okay, so again, angle at center is twice angle at circumference, which means to say O1 is going to be double 43. So I say angle O1 is equal to 2 times 43, which gives you 86 degrees. And as we said, for every statement you must have a reason. So you say angle at center, and that is sufficient. Okay, with saying that, you'll get your full mark for it. Okay, angle at center. If you want to say the full theorem, it's fine. Angle at center is twice angle at circumference. So now at this point also, we start populating our diagram, which means to say, start filling in information on the diagram. Why do we do that? So that when looking at the diagram, from first glance, we can see exactly what we have calculated or what we have in for the next calculation. Okay, so there we got that. In question B, for question B, the question was to calculate the angle B1. So to calculate B1, we know that B1, we need to set up a triangle, an equation here to calculate B1. However, B1 we know is going to be the same as C1. Why is that the case? Because that is your radius, your radii. One radius, many radii. Okay. So again, that is not, these markings are not on the diagram, so I have to state it. So we first say that OB is equal to OC. Why is OB equal to OC? Because that's your radius, your radii. Okay. Now B1 is equal to angle C1. Why is B1 equal to C1? Because it's angles opposite equal sides. Okay, you can't just say isosceles triangles there. If you say an isosceles triangle, you lose the mark. You must say, in these two types of isosceles triangles, it's either angles opposite equal sides or sides opposite equal angles. This case here would be angles opposite equal sides. Alright, so now we can say that B1 plus 86 plus C1. But remember, C1 and B1 is the same. So I'm going to rather say twice B1 plus 86. Why do I say twice B1? Because then I work with one variable only. Okay? And that's equal to 180 degrees. Why is it 180 degrees? Because it's the sum of triangles, and it's triangle COB. This part here does not have to be said, okay? But the reason why I say it is that if there's more than one triangle in the diagram, okay, and your examiner marks you or your script, and he's trying to make sense of the route you are following, then he can see exactly which triangle you are referring to, okay? But if you leave that out, you won't lose any mark. Okay, so this now becomes an equation. So twice angle B1 is equal to 180 minus 86, which is 94. Divided by 2, it's simply going to be 47 degrees. Okay. Okay, so now we're looking at example 2 on page 282. We are given given as circle center O, with points A, B, and C on the circumference. Then we are told that OA is parallel to BC. So if lines are parallel, we know that alternate angles are equal, so that angle and that angle is equal, as well as that angle O with that angle B, alternate angles are equal. We also know that corresponding and co-interior angles can apply, but none of the two are evident in this diagram. Remember, when we're using corresponding, co-interior or alternate angles, we must state which lines are parallel. Okay. So saying that, we are then told that OB and AC are drawn. We are told that angle A is 20 degrees. You must prove that angle B is double angle A. So to prove that angle B is double angle A, if we prove that angle B is 40 degrees, we've done the job. Okay? Why? Because angle A is defined already. Okay? Angle A is defined as 20. So 2 times 20 is going to give us 40 degrees. Okay? So again, in geometry, we won't go from the straight into that. Okay? We first have to go to another angle and then come back. But we already know that angle B is angle B is the same as angle O, because of the fact that it's alternate angles. But angle O has a relationship with angle C. Alright? However, C is alternate to angle A. Okay? So let's go with that. So firstly, angle C is equal to 20 degrees. Why is angle C equal to 20 degrees? Because it's alternate angles, with AO being parallel to CB. Okay? So there's your 20 degrees. Now, angle at center is twice angle at circumference. Okay, I'm sketching a lot on this diagram here. But as you can see, angle at center is twice angle at circumference. So in other words, AOB, or angle O, is equal to 40 degrees. Angle at center. As I told you before, you can write our theorem out, which says angle at center is twice angle at circumference, but this is suffice. This is enough. So that is 40 degrees there. Again, you see me populating the diagram. Okay, and then the alternate angles coming in here again, this way. Okay, so angle B now is equal to 40 degrees. Why? Because it's alternate angles, with AO being parallel to BC. Okay, AO is parallel to BC. And now in conclusion we can say, therefore, angle B is equal to double or twice angle A. Okay. Okay, so now we will be looking at Theorem 3. In Theorem 3, we are told that if this is your diameter, now remember that if angle at center is twice angle at circumference, this angle at the center here is going to be 180 degrees. So if that's 180 degrees, that is 90 degrees. So if this is the case, if that's a diameter, then you will always have 90 degrees at the circumference. Okay, and the reason is, as you can see, angle in semicircle. Now Theorem 3b, which is the converse. Now the converse is basically the reverse. So the reverse of 3A is basically 3B. If that angle there, the angle at circumference, if a chord subtends 90 degrees at the angle circumference, then this chord has to be a diameter. One of two things I can write there is either I can write it's the converse of angles in a semicircle, or I can write chord subtends 90 degrees. Any one of those two reasons. So it's either chord subtends 90 degrees, or I can write converse of angle in the same segment, which is the reverse of angles in the same segment. Okay, so now we're looking at example 1 on page 285. We are told that if a chord subtends an angle at 90, we explained the theorem already. So we are given that XOZ is the diameter of circle center O. Okay, so if this is the diameter, remember what did we say? If that's the diameter, the angle at circumference, or the angle subtended at circumference will be 90 degrees. So that W1 and 2, the combination thereof is going to be 90, and this angle W, angle Y is also 90. Okay, and the reason they in both cases are angle in semicircle. Then we are told that W and Y are two further points on the circumference of the circle, which is also given there, WX, WZ, XY, ZY, and WO are drawn. Then we are told that O1 is equal to 68 degrees. X2 is 42 degrees. The question says calculate the magnitude. Now the magnitude is basically the size. Calculate the magnitude of, in the first case, x1. I want you to calculate x1. So there's many ways of calculating, not many ways, there's two ways. Okay. I can go and calculate O2 first, the angles in a straight line. Then we can say that angles at center is twice angle at circumference. Can you see here? That angle at center there is subtended by chord WZ. Angle at center is twice angle at circumference. Okay. Otherwise, what you could have said was that x1 is equal to w1. Why? Angles opposite equal sides, your radius OX and OW, and then we can go with sum of triangles. Okay, but I think angles in the straight line first, and then angle at center is going to be easier. So we first say that angle O2 is equal to 180 minus 68. Okay, so it's angles in a straight line. Okay, so 180 minus 68 is going to give you 112. 180. Yes, it's 112. So that's going to simply be 112 degrees. Okay, now again, angle at center is twice angle at circumference. Makes sense? This is from the previous theorem. Again, angle at center is twice angle at circumference. So x1 is equal to 112 divided by 2, which gives us 56 degrees. What's the reason there? Angle at center. Okay, again, if you want to say angle at center is twice angle at circumference, the whole theorem, the whole reason there is fine. Otherwise, this will get you the full marks anyway. Again, note that I'm populating the diagram. Okay, I'm filling all this information in on the diagram. Okay. Okay, so look at B. Okay, I just realized now I marked the wrong angle there. It had to be O2 had to be 68. But I will go through with that angle being 68. If that angle is 68, this is the route we will follow. Okay, instead of redrawing the whole triangle. So in B, they want you to work out Z1. Okay, so Z1, as you can see, this is in a triangle here. Okay, so we firstly know that that angle is going to be 90 degrees. Remember, if it's not on the diagram, I need to state it. So I'm going to say that XWZ, angle XWZ is equal to 90 degrees. Or I can say angle W1 plus W2 is 90 degrees. Reason? Angle in semicircle. Okay? So now we're going to go sum of triangles. So Z1 plus 90 plus 56 is equal to 180. So the same as saying 180 minus 56 minus 90. Okay, and this is sum of triangles. That is your Greek symbol for sum of, or S, capital S. Sum of triangles. Again, I name the triangle I'm working in. It's in triangle XWZ. Again, do I have to say this part here? No. If you leave it out, you won't lose any marks there. Okay. So that would simply be 180 minus 90 minus 56 gives us an angle of 34 degrees. Alright. The angle is 34 degrees. That's one way of looking at it. Otherwise, we could have also said that which would have been easier, is that angle at center is twice angle at circumference. Can you see here? So angle subtended at the center here is twice the angle subtended at circumference. Okay, again, this, it was according to the introduction, that angle was 68, not this angle here. Okay, but I'm applying the rules as I'm going along here. Okay, so if this angle had to be 68, then this is the route that would have been followed. Okay. Let's look at C. In C, they want you to work out Z2, which is this angle here. Okay. So for Z2, I need to go with sum of triangles here. But we're shorting this angle here, angle angle Y, sorry. But we know that angle Y is 90 degrees. Why? Angle in semicircle, and then sum of triangles there. So firstly, angle Y is equal to 90 degrees. Why? Angle in semicircle. Angle in semicircle. Okay. So Z2 is simply going to be 180 minus 90 minus 42 degrees. Which gives us 48 degrees. And what's the reason here? It is sum of triangles. And it's triangle X, Y, Z. Okay. So I'll do one more. Okay, so the 6 out of exercise 9.3 on page 288. This is a question that the learners normally have issues with. Okay, they always come back the next day with the sum being the problem. Okay. What I would also suggest is for these type of videos, I would have done all the odd numbers only. Okay, so if the learners have an issue with the exercise, they would refer back to the video. Okay. So in question 10, we are told that given AOC is the diameter. So if AOC is the diameter, then this angle here would be 90 degrees. Okay, I just pencil that in. So so that we know. Then we are told that B and D are two further points on the circumference of the circle. Then we are told that A1 is equal to X. Write the following angles in terms of X. So we must write the following angles in terms of X. So angle A. And question A. They want you to work out B1. So of course B1 is also equal to XY because the fact that it's your radius there. But since it's not on the diagram, I have to state it. So firstly, we're going to say that AO is equal to OB. Why? It's your radii. Okay, which means to say now that angle B1 is equal to X. Why is B1 equal to X? Because why? Angles opposite equal sides. Angles opposite equal sides. So there's your X. So there's B1 in terms of X. Alright, let's look at B. Angle O1. So we know that x plus O1 equals 180. So angle O1 plus 2x is equal to 180 degrees. Why? Sum of triangles. And it's triangle AOB. Alright. So angle O1 is equal to 180 minus 2x. Again, I put that also in the diagram. Remember, we're populating the diagram. Okay. Let's change our color. Let's go to red. C. C, they want to work out angle C. They want you to work out angle C. Again, angle at center is twice angle at circumference. Can you see here? Angle at center is twice angle at circumference. So angle C is going to be a half of 180 minus 2x. Angle at center. Again, angle at center is twice angle at circumference. So I divide by 2, 180 divided by 2 is 90 minus 2x divided by 2 is x. So angle C is going to be 90 minus x. Okay. Then I want you to work out angle D. Okay. So angle D, which is this angle here. Again, can you see the angle at center? Is twice angle at circumference. Okay. Angle at center is twice angle at circumference. So angle D is also 90 minus x. Angle at center. Okay.